Welcome to Math 1314. This is section 1.2. In this section, we look at applying what we learned in the last section to word problems. Now don't panic. Yes, word problems are difficult, but we're going to work our way through these and it won't be as bad as you might think. Alright, so in question 1, we have a mixing problem. I want to mix two things together. So in this first picture here, I have this item. I want to add it to this item. And I want to create something new. So first off, let's talk about the things we need. In these mixture problems, there's two things. Each of your solutions has a particular concentration. For example, my first solution here is a 6% solution. Doesn't matter what it is, a mixing of what, but it is a 6% concentration. The second one is a 10%, and so I'm taking a 6 and a 10, and I'm making a 9. Now let's talk about some practical situations here. If I take a 6 and a 10 and I mix them together, I can't get a 16. I can't get a 13. My resulting mixture has to be a number between 6 and 10. So I'm taking some 6, adding it to a higher concentration of 10. It's going to bring this concentration down to 9%. The second important thing, I have a certain amount of each one. In the first case, I don't know how much. That's what we're trying to figure out. I'm adding it to 4,500 gallons of my 10%. And I'm going to get a new amount. Well, if I'm mixing two things together and I don't spill anything, then the amount in the new part is just the sum of my first two. And that's really as hard as this problem is. Concentrations, which I write as a decimal, so 6%. 6 divided by 100 is 0.06. 10 divided by 100, 0.1. And 9 divided by 100 to give me 0.09. Alright, so let's see. What do we do? First off, I'm going to let x represent the amount I need of the 6%. We know the second one is 4,500 gallons, and the final amount is just the sum of those two amounts. Now, we collect all of that information in a chart. The chart has a couple of things in it. It has our concentration, which is 6%. Now the 6% is 0.06, 10% 0.1, 9% 0.09. So that's our concentration. The amount was x, 4,500, and x plus 4,500. Now to get this last row, all we do is multiply down. 0.06 times x is 0.06. 10% is 0.1 times 4,500. And 0.09 times x plus 4,500. That's it. This row of our algebra forms our equation. And so now, when I've got this item plus this item, it must equal to the last one, because I'm adding the first two solutions together. And that's what they're telling us here as we're stepping through this. So here's my first one, plus the second, and here's the right-hand side, our result. And so as I work through this, let's see, 0.09 times x, 0.09 times 4,500 is 405. So now I want to get numbers together and x's together. Now I'm going to move things so that I get positive numbers. I'm going to move the 0.06 to the right and the 405 to the left. I do the subtraction and I get 45 and I get 0.03x. And so when you divide by 0.03 to get x by itself, we find x is 1,500 gallons. So what does that tell me now? So here's my 1,500 gallons of my 6%. I'm adding it to my 4,500 gallons of 10%, and I'm going to end up with, well, add the two numbers together, and I get 6,000 gallons of the 9%. Just that simple. Concentrations, amount, form your row for your algebra, and then we solve the problem. All right, let's see what else. So here in question 2, another mixing. A nurse is going to mix 60 cc's of a 50% with a certain amount of a 30%. Okay, so I've got a 50 and a 30. I'm going to get a result. Now the result has to be between 50 and 30, and it's going to be a 45% solution. So how much of the 30 should we use? All right, so let's see. Here's the 50%, 30%. Here's my result. Make a row of your concentrations. Make a row for the amounts. 60, I don't know how much, and the result is x plus 60. I do the algebra. Now, how do we do the algebra again? Well, we simply multiply downward. So 0.5 times 60 is 30. 0.3 times x is 0.3x. 0.45 times this sum. And so I'm adding the first two together. You see, that's all we're doing here. Adding the first two together must equal to the result. All right, distribute the 0.45 times the x times the 60. And so I get 0.45x, and 0.45 times 60 is 27. All right, I want to get the x's together and numbers together. So 30 minus that 27 is 3. 0.45 minus 0.3 is 0.15. And so I divide 3 by 0.15 and I get 20. So what is that? That's 20 cc's of the 30% solution. So how much would I get in the end? Well, we had 60. I'm adding 20 we just found. So my final amount would be 80 cc's. They didn't ask us that, but it's good to know that. Also, on a side note, when you hear the word 80 cc's, that's if you look at a shot. And 80 cc's is the same in chemistry terms as 80 milliliters. All right, in question 5, we have a problem involving distance, rate, and time. Now the relationship here is distance is equal to rate. Rate is just how fast am I going, flying, driving, walking. So it would be in terms of miles per hour, feet per second, meters per hour, it's how fast. And the time is the length of time. So the formula you would see is D equals RT. So what's going on in our problem? We have an airport. An airplane flies toward LA, and it takes 4 hours to do that. Airplane leaving that same airport flies to New York, and it takes 4 hours to get there. Okay, so I have a length of time. So I've got the T. What about how fast? Well, we're wanting to find that out. So let's see. What they tell us is we have a certain speed going from the airport to LA, and because of some westerly winds pushing us toward New York, we are going 50 miles per hour faster. So if this is x, this would be x plus 50. All right. Now, what else do they tell me? They tell me that the total distance of the whole process is 2,464 miles. Well, that total distance would be distance 1, this left half, plus distance 2, which is the right half. Well, let's see. Distance is rate times time, so 4x. The distance on this piece is 4 times x plus 50. And when I add the two distances, I get 2464. So we simply distribute 4 times x, 4 times 50, and I get 4x plus 200 is that number. So 8x is that number, and now I simply divide both sides by 8. And so my speed going to LA is 283 miles per hour, and my speed going to New York, well, how much is that? I don't know. I panic. No, don't panic, because we know it was 50 miles per hour faster. So simply add on the 50, and that was our speed flying to New York City. All right, in question 4. Question 4, we're going to create some concrete. Concrete is a mixture of cement, sand, and gravel, little rocks. And I need a proper proportion for this to work. And the ratio, see this word ratio, of how this works out is cement to sand to gravel is 1 part cement to 2.4 parts sand to 3.5 parts gravel. So I need the most of the gravel. And so they're going to give us a 300 pound bag of sand. Okay. And they want us to figure out the amount of cement and gravel. So I just form cement to sand is 1 to 2.4. And so now fill in what we know and what we don't know. So 1 for the cement, I don't know how much will go. For the sand, we've got 300 pounds. So I've got this ratio now. I cross multiply, so multiply down and up. So 2.4C is 300. So divide by 2.4, and I get 125 pounds for the amount of the cement. Sand to gravel. Well, let's see. Sand was 2.4. Gravel is 3.5. And so again, fill in what we know. Sand, G for gravel, I don't know. 2.4 and 3.5. All right, cross multiply again, down and up. 2.4G is 3.5 times 300, which is 1050. So divide by 2.4, and the amount of gravel is 437.5 pounds of gravel. Now, if you wanted to also use the ratio of cement to gravel, you could do that too. We didn't need that, but if you wanted to go that route, cement to gravel, well, what was that ratio? Well, 1 to 3.5. And so you could fill in the answer we got for cement, which was 125. Put that over G for gravel, 1 over 3.5. And if you solve this, you'll get exactly that same amount. So whenever you make something, typically there's a ratio that you need to form to be able to make it. And so finally, we just fill in the numbers in for the pieces that we used. And in our last problem, we have a ratio involving property tax. So on a $140,000 house, the tax is $1,100. So what's the rate on a $210,000 house? Well, this is a ratio. We're assuming that for this problem. So let's see. I just put the amounts here. The tax for the first house equals, and my second house, I don't know what the tax is. That's what we're trying to figure out. So to simplify this, first I'm going to reduce these numbers. I can get rid of all these zeros, and it's 14 over 21, which I can reduce taking a 7 into each one. And so we get 2/3 is 1,100 over h. All right, so that's a multiplication. That's this multiplication. And so when I solve for h, I simply divide both sides by 2, and the amount of tax on the $210,000 house is $1,650. So again, a ratio to solve this problem. So hopefully you didn't find the word problems too terrible. Watch the video. Remember that the mixing problems 1 and 2 all depends upon making that table of concentrations, amounts, and then the final row, which is all the algebra.